Hi everyone, I'm Li Hui, a professor at the College of Forestry and Landscape Architecture in South China Agricultural University. It is an honor to share some of my studies with you. Today, I'm going to talk about the Chinese approach to the theoretical study of urban growth boundary. How to plan in a unified manner all kinds of spatial configurations and scientifically delimit corresponding boundary for implementation is an important guarantee for the role of urban ecological system functions and benefits, so as to cope with dramatic urbanization of large and medium-sized cities during rapid urbanization, which invades the surrounding ecological land and waste of land resources, as has become the key and difficult points for making sustainable development strategies. My speech is divided into four parts. First is about the research background and the domestic and international research progress of urban growth boundary. Second is Chinese approach to urban space growth boundary. And third is a case of Chinese practice of demarcating rigid urban space growth boundary. At last, I will talk about conclusion and discussion. First part is about the connotation of urban growth boundary. The concept of urban growth boundary was originally by Salem City, USA in 1976 as the delimited boundary between urban land and rural land. It worked to resolve the conflict between the city and the two countries of Marion and Polk in urban planning and management. It specified the land within the boundary could be used for land development for urban construction. The land outside cannot be used for urban construction. This conflict ended up with the emerging of the first urban growth boundary. After that, Western scholars supplemented the definition of urban growth boundary. Siebert Richard believes the urban growth boundary is to draw a line outside the city to curb unchecked expansion of the urban area. Benson David defined the urban growth boundary as an important boundary to tell the urbanized area from suburb ecological reserve space, as marked by the government on the map, whose implementation is guaranteed by zoning and other police tools. In terms of urban space, it is directly reflected in the change of landscape spatial pattern, such as the changing application functions of all kinds of land, and in terms of implementation, it is dependent on the demarcation of various area spatial boundaries. Whether urban and rural artificial construction areas or natural and semi-natural urban ecological system composed of rivers, coastline, farmland, massif, country park should have clear boundary to control and guide urban spatial configuration. Correspondingly, the boundary includes natural, semi-natural, and urban town and village boundary, or known as the boundary between construction area and non-construction area. By 1999, in America, more than 100 city or rural areas had established their urban growth boundary, and 3 states, which are Oregon, Tennessee, and Washington, have passed the decree for urban growth boundary, covering each whole state. The most famous urban growth boundary is located in Portland metropolitan area in Oregon, USA. In Western countries, Scholars have explained the implications of urban growth boundary from different perspectives. From the perspective of demarcating its spatial scope, a metropolitan area should have quite clear-cut boundary, which may be river, coastline, farmland, massif, suburban park and so on, and shall not be blurred or even encroached along with the expansion of the city. To sum up, UGB is the boundary between urban construction land and non-construction land, and is a technique approach and a policy measure to prevent the urban area from disorderly growing, and the boundary for a city to expand in space during a period. And these are some international qualitative demarcation methods of urban growth boundary, which include qualitative demarcation methods of urban growth boundary and layer-by-layer detailed demarcation of urban growth boundary. And these are international quantitative demarcation of urban growth boundary, as shown in this table. Okay, the concept of urban space growth boundary was introduced in China in 1990. In 2006, the urban planning making method initially put forward the urban space growth boundary. In 2014, the National New Urbanization Plan reiterated the importance of limiting urban development boundary and optimizing spatial expansion structure, and required the demarcation of boundary for megacities. Chinese scholars concentrate our UGB research on the domestic and international UGB differentiation, interpretation of urban space growth boundary, and the demarcation method of urban space growth boundary. And these are some domestic quantitative demarcation of urban space growth boundary. International and domestic growth boundaries have different background. Western countries, mainly represented by the United States, apply growth boundary mainly to handle the expansion of the urban area and the receding central city caused by suburbanization. Compared with the United States, the suburban land is even more compact in China. The application of growth boundary is mainly to cope with drastic expansion of large and medium cities during dramatic urbanization, encroaches surrounding ecological land, and results in the waste of land resources. Therefore, the urban growth boundary of the Urban and Rural Planning Law and the Urban Planning Making Method is based on urban land use evaluation and research on urban development direction, and comprehensively determine the urban space growth boundary that urban development may involve and other land regulates. Urban growth boundary has formed some research basis, but previous research is seldom aimed at urban spatial functional region to form the spatial pattern that guarantees national and regional ecological security and socio-economic coordinated development. Part 2 is about Chinese approach to urban space growth boundary. The urban space growth boundary in this research refers to demarcated functional area and a corresponding boundary for coordinating urban ecological system service function with the urban and rural spatial area scope to ensure maximum ecological benefits and no spatial overlapping. Corresponding to natural ecological system and artificial and semi-artificial ecological system, it can provide urban ecological system service function that can meet and sustain the condition and process. Specifically, it includes ecological protection, urban function system role, and stable food supply, and like main ecological system service function, which are corresponding to the ecological red line of Forestry and Environmental Protection Department. Urban growth boundary of housing and urban and rural development, and basic farmland protection boundary of Agricultural Department. Breaking the conventional fragmentation under the theory and framework of giving the overall role of urban system services function. Explore integration of multiple regulations, scientific and rational methods. From space and quantity, we can ascertain the street management and control of key ecological function area, biological diversity area, ecological environmental sensitivity area, and fragility area, so as to maintain ecological security pattern, guarantee ecological system function, and support the sustainable development of the economy and the society. With ecological system service value, topographic slope, soil erosion modulus, geological disaster rate and continuous rate, and like farmland ecological quality representing indexes. Construct the indexes for farmland to be listed as basic farmland. Put forward basic farmland demarcation comprehensive appraisal method. In combination with the above material flow research, synthesizing spatial form and ecological security, ecological carrying capacity, and so on. Based on G's platform, realize all index quantitative analysis and farmland quality comprehensive index estimation. Based on this, we ascertain the time-space configuration scheme and demarcate the basic farmland protection boundary. We calculate the bearing capacity of population and socio-economic activities, evaluation of overall bearing capacity as important reference factors of growth boundary. Applying cellular automaton-based sleuth model through dynamic monitoring and mechanism exploration of urban development, we predict the growth trend of the city in the future, form urban expansion scenario under different protection intensity through different parameter setting, evaluate the environment impact on different scenarios to provide basis for demarcating urban growth boundary. And in combination with the ecological red line and the basic farmland protection boundary demarcation results, and natural and historical boundaries, to finally decide on the urban growth boundary. The above three urban growth boundary demarcations are not separated, but comprehensively consider the balance between growth and constraint, demand and supply, and the impetus and resistance of functional urban region, ecological function area, and agricultural function area, based on the timeliness of growth boundary. Part 3 is about the Chinese practice of demarcating rigid urban space growth boundary. The research takes the Lujiang River basin as a typical case, with high mountain and deep valley, drastic elevation, intense altitude vertical zonality. With complicated climate, soil, and vegetation, it creates conditions for various natural and geographic landscapes, ecological environment, and biology. Therefore, the evaluation of ecological essentiality is planned to use the single-factor superposition method and the logic rule combination method combined, and at the complexity between evaluation factors. We use logic rules to establish ecological essentiality analysis criteria, and based on this, we have judgment and analysis. And with geographic information system technology applied, we have the final importance evaluation results. And that the characteristics of this area, we will have soil erosion sensitivity evaluation and habitat sensitive evaluation to conduct analysis and evaluation, to synthesize and have the ecological important evaluation results of this area. Factors involved in soil erosion include climate, hydrology, landform, soil and vegetation, and conservation of soil and water. Referring to the general soil erosion equation, in combination with the characteristics of this research area and the 3S technology feasibility research, we determine the research area oil erosion sensitivity evaluation factors, including water erosion, landform, soil geologic factor, and land cover factor. According to the specifications for soil erosion sensitivity evaluation complied by the State Administration for Environmental Protection, in combination with the actual situation of the research area, all influencing factors have classification and standard for soil erosion sensitivity evaluation as shown in Table 4. And this is the equation of soil erosion sensitivity comprehensive evaluation index. First, we convert each layer of data into grid data, and to ensure the data precision and reduce data redundancy and improve stacking velocity, we can have rational polygon integration, and then we have map layer overlapping through union command. And finally, overlap the 4 map layers. And according to classification standard, we assign value to the classification results of 4 factors. Through ArcGIS software, we compile equation against the above equation. And after operation, we have the results. And then, through classification standards to give evaluation classification, to have evaluation results, which after classification mapping, we have soil erosion sensitivity comprehensive evaluation distribution map. According to the actual situation in this area, the habitat sensitivity evaluation is mainly based on the species richness of the ecosystem and the distribution of national and provincial protected species to conduct evaluation. According to the specifications for habitat sensitivity evaluation compiled by the State Administration for Environmental Protection, the classification and standard for habitat sensitivity of biology diversity based on species protection is shown in table. Meanwhile, according to the richness of the above protected species in one ecosystem, the ecosystem sensitivity of the research area is classified. Taking different ecosystem type sensitivity grade as classification standard, we reassign value to the interpreted vegetation types to generate new map layer. And with G spatial analysis and statistics function, we conduct evaluation. According to the alpine and gorge region complex ecosystem features of the research area, ecological essentiality mainly includes the combined effect of soil erosion sensitivity and habitat sensitivity. From habitat extremely sensitivity and soil erosion extremely sensitivity area to habitat insensitivity and soil erosion insensitivity area, it can be divided into 5 levels: extremely important, very important, important, commonly important, and not important. According to the above evaluation criteria, we can have the area scope and area size of 5 levels ecological essentiality grade distribution of the research area. Ecological essentiality mainly considers the comprehensive ecological service functions, including water source conservation, water and soil conservation, biodiversity protection, and disaster prevention and reduction. According to the features of alpine and gorge region, we should combine soil erosion sensitivity and habitat sensitivity to analyze. To consider both soil erosion sensitivity and habitat sensitivity, and the evaluation results reflect the results of comprehensive evaluation. Habitat sensitivity is closely related to vegetation and wildlife distribution, and habitat sensitivity area is always most ecologically essential area. So the ecological essential area and its essentiality should be consistent with the habitat sensitivity and is the area of the richest biodiversity, while the soil erosion sensitivity is mainly related to precipitation, soil texture, and slope, and the soil erosion highly sensitive area is always an area of high ecological essentiality. The consequent ecological essentiality evaluation results will provide scientific basis for demarcating rigid urban growth boundary of the research area. Thus, we will summary like this. International experience and domestic tactics tell us that Urban space growth boundary includes rigid and elastic geo implications. The rigid growth boundary comes from the perspective of protecting non-construction land around the city, and is the ecological security bottom line for sustainable urban development. And it has strong operational significance and embodies the ultimate scale of the city. The elastic growth boundary comes from the perspective of growth of construction land, a dynamic boundary of urban space expansion of different periods, and it reflects the stage features of urban development. The principle of urban planning shall shift from expansion planning to limiting urban boundary and optimizing spatial structure, and consider urban development stage to demarcate the rigid and elastic urban development boundary. Based on the above investigation, this research puts forward an integrated comprehensive method applied to urban growth boundary demarcation. The integrated comprehensive method refers to comprehensive qualitative and quantitative consideration of integrating ecological red line, urban growth boundary, and basic farmland protection boundary, with coordination and integration to scientifically define urban function boundary. Firstly, based on sensitive structure, fragile process, essential function, and ecological bearing capacity, we can conduct ecological essentiality evaluation to demarcate the land which is most essential in ensuring ecological system service function, biodiversity, and habitat protection into the ecological red line as the rigid boundary for urban ecological protection. Secondly, we can use the land evaluation and site assessment method to define priority farmland from the perspective of ecosystem service value. Farmland natural quality, utilization conditions, space form, and ecological security, and consider population flow in this area to research and calculate its ecological bearing capacity, to finally demarcate the basic farmland protection boundary as the rigid boundary for urban material support. Thirdly, we can refer to the layer-by-layer detailed method of Portland Plan 2040 to demarcate the urban growth boundary. Based on different scenarios, we determine the ultimate development mode and demarcate the urban growth boundary as the elastic boundary for urban construction and development. According to the institutional reform of the State Council in March 2018, the planning function of the newly organized Natural Resources Ministry will go to National Development and Reform Commission, which mobilized to compile the main function area plan. This will surely end all departments have fragmented division in spatial planning to form new land spatial planning considering all functions and integrating multiple regulations, and will lead in demarcating urban growth boundary, and will come up with new status quo and trend. This paper puts forward the demarcation methods for urban growth boundary in the new situations, and more technologies was our first research efforts. Thank you for your attention.